Today we are going to start on the purification component of metabolites of lactic acid bacteria. So how you can grow, and after the growth, how you can purify especially bacteriocins or any metabolite if you want to isolate proteins, carbohydrates, acid out of it, how you can do this. So in the cultural part, Professor Todoro has shown you that how you can grow the culture in the lab, and after the growth, what are these important metabolites and how you can extract that is important. Just growing the culture is one aspect of learning the technique, but other aspect is how we can maximum utilize for biotechnological application. So any things related with that we can discuss. So I think without spending time, we can start in the lab only. If you group 1, group 2, you have already made it. Those persons related with the group, they come directly in the lab, and I will show the demonstration of purification of bacteriocins from the culture broth. There only we can discuss it. And if you have anything related with the question, there we can interact. Meanwhile, with the other group, Professor Todoro will interact here. So group 1, if all are here, if anyone is missing, it's okay. Come with the group wise. We have 4 groups. Okay, so if someone is missing, it's okay, they will join later. But come with the group wise only, don't come with the mixing of the 2 group and then again confusion is not, right? So I will wait in the lab to come the group 1, 2 and 3, 4 to demonstrate it. Happy school group. Thank you. I'll just join you later.
I will go to check the plates as well. Someone from group 1?
If there is a difference in the morphology, they secrete different type of compounds. Why they are important? Not because of their shape or their size or their structure. Why? Because of certain important function they perform. They are important. Why? Because they perform certain functions. These functions are related with their metabolites. What they are producing, what they are making inside, both are important. Some components are inside the bacteria, some components they secrete outside. You can be interested in both. If you want inside one, you can use. If you want outside which is secreted by bacteria, we can use, right? If you want to use inside one, you have to break the cell. So how you get it? You have to break the cell. There are different methods we can discuss later. It's not part of it. And if you are interested in outside something which is secreted by the bacteria, then it is easy for you. You don't have to kill the bacteria. Like they grow in a culture broth. Abhi aapne dekha hoga study? That they grow this bacteria in a culture broth. That broth culture is something which is a liquid medium, right? Like this, they are having this, right? Suppose this is a medium. So they grow it properly in this. And whenever you grow it properly, there is a condition that you provide the condition and there is a growth. And while growing, it can secrete the compound in the medium. It will utilize the nutrients and secrete the different metabolites. Generally, it is considered to be secondary metabolites secreted by these bacteria. Now, what happened that if you are interested in one of the molecules like bacteriocin, because you are studying bacteriocin since last 2 days, so you might be knowing that it is a secretory antimicrobial protein, right? It is secreted by the bacteria and can be used for different functions. So what we are going to do that how you separate this bacteriocin in the purified form. Because if you want to see the study, you have to purify it. Because it is already secreted in the medium. When it comes in the medium already contains several compounds. Like this is a medium and it looks like that it contains several color, pigmentation and the protein and the carbohydrate, everything is there. And now one more compound has come inside this. So if I give it to you, you can say, no, it is a mixture of compounds, it is not a one bacteria, right? So most typically what is done in case of purification, like this is a crude mixture of protein. So one of the technique people generally use is the way that how to precipitate that. If you make a biased precipitation means if you precipitate protein but not carbohydrate, not the lipid, right? So it is considered that if you allow for precipitation, that will be there only if you increase the hydrophobicity. It is a hydrophilic because everything is dissolved in the water. Increasing the hydrophobicity means if you increase the amount of salt, you add the salt, hydrophilic nature will decrease, hydrophobic nature will increase, and that will allow to adhere one compound to each other. And you know proteins are hydrophobic in nature. Some of the amino acids are hydrophobic and they present on the surface of the protein. So they like one protein another protein, they are dissolved freely moving in the solution. But if you include the hydrophobicity, they comes like this and adhere. So it's like a one protein, two protein, three protein, make a clump of the protein and get settled down. And now your purpose is soluble. Because you have removed other things which are soluble, but proteins are precipitated, so they will get settled down. Now they have put this, they have made this ammonium sulfate is one of the most commonly used salt. And this salt, if you add in it, it will increase the hydrophobicity, right? You just one spatula and put it in there. So what is there? It will be dissolved. Once it will dissolve, its ionic strength will increase. Leave it. So it becomes solubilized. Once this concentration is increasing, like it is solubilized, if you add another spatula, so what we are doing, we are increasing the concentration of salt, and it becomes like saturated, like slowly, right? Now, your protein functions only if there is a saturation. Because different, you belong to this group? So different proteins saturated at different level of concentration. Maybe you are adding little amount of protein, but it is not sufficient to precipitate the protein, so you need high amount. So you slowly you go at that, and it will be getting that some concentration is very important, which is responsible for the precipitation of protein. Right? See, I added one amount. Now you can add another one. Right? So see what she did, she increased the concentration. So try to do that once it is solubilized, only then you add the other one. If it is not solubilized, then you cannot add the other one because there is no meaning. Once it is saturated, only then you have to add to make it precipitated. Right? For example, we are having this concentration from 0% started, and then 10%, 20%, 30%, 50%. Right?
Yes.
And you have a mixture of protein. If that mixture of protein, for example, all protein will not need a high concentration.
Yes.
Which protein will be precipitated at low concentration? Which at high concentration? No, not you. Let them others. Because these people are already knowing. So what is there? For example, if size-wise, there are other factors also. One of the factors is size, right? If protein is bigger in size, and one protein is smaller in size, because it is a mixture of protein. So based on size, you can differentiate, distinguish. What is being that if I add X amount of salt, the hydrophobicity is there. Which protein will precipitate first, the bigger or smaller? Bigger will have more surface of interaction. The smaller there is no surface, it's moving like a zigzag, they are moving. But the larger will, chances of collide will be more for the larger one. They don't have space, they're moving, they're catching this, they're catching that, and that. So it will become bigger and then get sound. So that is the concentration which is allowing the larger protein to precipitate. But the smaller is moving in the solution. Now what technique we can do? Separate it. Right? Just centrifuge.
Yes.
So what you are doing? You have removed X amount of protein from the mixture. Now the YZ is present again in the mixture, right? Take that mixture again, right? And add the salt, increase the level of salt. For example, from 20 to 40, you did 40. You make it 40. Add more. One spatula. We don't know how much, but you add one or two. Very increasing roughly. Very time. That the concept you should be clear. What make करके डाल दो वैसे कर सकते हो.
So she's weighed according to the volume of.
But spatula she doesn't know how much amount she is adding this. You add another one. So what they are doing, that they are taking the supernatant where the protein was soluble that time, but now we are adding another protein is now make it precipitate. The smaller one. Because for a smaller one, you need a higher concentration so that their surface area is low. If the surface area is low, you need more hydrophobic situation. Right? So in the middle, you got some precipitation. Now you have one lot number one, that the bigger protein. Now you got some precipitation, you can centrifuge it. So you got lot number 2, again centrifuge one protein, right? Now again you got some solution there, that may be protein. Try to increase the concentration, maybe 90%. Go to the maximum the way you can to solubilize it, right? So if it is a 90%, the smallest even will be precipitated down. Are you getting my point?
Yes.
So that way you can centrifuge. Now you got the 3 lots of proteins, largest, medium and the smallest. Now how I remove this from the mixture? Precipitation. What I did, that I have given a mixture of the protein, but based on the size, I have separated into 3 proteins from the solution. I extracted from the solution. Now my protein is based on the size. The larger, the smaller and the smallest. Right? Now we don't know where is my protein or bacteriocins. Right? Go for activity. Check the activity जैसे zone of inhibition बताया था. Check the zone of inhibition. All the sample will not show zone of inhibition. The largest, smallest and smaller. Somewhere you can make it 10% gradient. 10% precipitation, centrifuge. 20% precipitation, centrifuge. 30% precipitation. So you have 10 different lots and check the activity of each. Suppose I am getting the activity in 40%, 50% like that. Right? So I can remove the rest of the protein. Now I got the bacteriocins. Maybe along with some more protein there. It is not a highly purified. But it is a bacteriocin along with fewer number of contaminants. Are you getting the point?
Yes, sir.
So this is how you can optimize these conditions to enhance the hydrophobicity so that accordingly you can precipitate the protein of your desire. One of the basic method people use since very past when advanced technology was not there, that time they were using to precipitate it. So then you add it and get it precipitated. Maybe that it is not a highly purified, but what we are doing that we can have some of the mixture and that mixture may lead to some separation of protein. Like if you see this carefully, we are adding it to demonstrate you, but the principle allows that it need to be done slowly and slowly. Right? Slowly means if you add a pinch amount of salt, this salt should be dissolved. So that if you add another amount, it will allow to for the dissolutions better. And if you are not having that one, that will create a difficulty in the preparation. Right? This is what we can do. Suppose you got some separation and you got a mixture of this area that whatever is there, 10% or 20% is there. Now you can plan another level of purification with the chromatography. Right? This is what she is demonstrating, that there is a simple gel filtration column, and this gel filtration column is something that if you got the test the activity, right? And it has now fewer number of protein, right? ये चल भी रहा है? आपको पहले बोला था ना कि इसको चला देना. I told you, so
वेट करते हैं
I don't know. Can you see the what? Huh? इसमें तो ठीक है, ये तो है, ठीक है, कोई बात नहीं, चल रहा है। और डायरेक्ट 160
सर फास्ट से थोड़ा शुरू
ठीक है, चलो। So what they are planning that if you got a protein precipitated here, it may have certain amount of other proteins. Now how to remove that protein, right? You can go through the literature. There are several techniques of separation of this mixture of protein. One of the technique what we use for this protein is cation exchange chromatography. Right? Cation exchange chromatography is something the column is binding the cationic protein. The protein which has positively charged. So it is reported that most of the bacteriocins are positively charged. You might have seen in the lecture that the bacteriocins are positively charged. What do you mean by that? It can bind with the negative. So this resin is negatively charged, and if you load the bacteriocin over it, it will bind with the column. Right? So, but other proteins will not bind. So what is there? One is bacteriocin, suppose 9 are other proteins, right? And that is the mixture I got from the precipitation. Now I am loading this mixture over a column, right? This column will allow to bind all the cationic peptide or cationic protein. Maybe it will bacteriocin, maybe others. You can argue that there sir उसमें एक और भी हो सकता है positive charges आप कैसे कह रहे हो कि उसमें नहीं होगा because it is an unknown sample, right? जैसे medium unknown. You don't know कि उसमें भी कुछ cationic हो सकता है, agreed. But you will remove some others which are neutral, which are negatively charged, which are pigmented colors and anything that will not be bind, right? So if you load over it, you will get the binding of all the cationic protein, positively charged protein. So what we are doing, we are still decreasing the number of contaminants from there to here. Earlier it was maximum, we reduced to 10. Here maybe 2 proteins are other also binding with the bacteriocin. So one bacteriocin, 2 other cationic has bound. For example, you just remember, if I fall it here, right? So we are out of 10 protein we loaded, 3 proteins are bound, and 7 they are going directly flow through, she is collecting. For example, this is a simple technique you can do in your butyl column pack. You can connect with the peristaltic pump with this, and whatever you want to run, you can put it here. It will inject you at the rate of 1 ml per minute or 2 ml per minute that you can set it. This is a very simple, right? Now, only the purpose is that we to load over it. If you want to load, you can just put the tube here in your sample. It will suck it and load it, right? So if you load over it, the 7 proteins has gone in the flow through, 3 are in the bound. Now we can say that if some 3 are bound, how to remove it, right?
Yes.
By increasing the ionic strength of it, right? If 3 proteins are bound, increase the ionic strength by addition of NaCl. They add NaCl, right? If you add NaCl, the Na will bind tightly and protein will come out. So you are fractionated. Flow through means if you load the sample, anything is coming called flow through. So remove it. Those who are bound, add NaCl. That NaCl will remove these 3 proteins that we say eluted protein. Got it?
Yes.
So from the mixture, we got 10 and then here we got 3. Now my problem is that with the bacteriocin there are 2 other proteins also. Right? So if there are 3 proteins, okay, right? Out of these 3 proteins, all will not be of same size.
Yes, sir.
There are 3 proteins. तीनों का cationic nature था कि तीनों bind कर गया, लेकिन तीनों same size होगा ऐसा जरूरी नहीं. Right? Maybe very rare, but it is not. Probably it is not. So you have 3 proteins of different size. For that sake, they run a gel filtration chromatography. Gel filtration chromatography is a Cephadex column. Only you change the reagent And what it does, it allows the separation of protein based on size. Right? If I load a mixture of protein, 3 kDa, 10 kDa, 20 kDa, suppose, right? It will collect different samples, and these 3 different samples will have different types of protein. Now there are 3 proteins you have collected. Now you can go and check the activity. Which one is showing activity is your bacteria. Got it?
Yes.
Come out. Come out and come. Come here only, and this. Here, there. Come. आपको हर जगह अगर प्लांट का भी कुछ काम कर रहे हो ना, तो उस केस में आपको कभी-कभी ट्रांसफॉर्मेशन करना है, कभी-कभी रिकॉम्बिनेशन बनाना है, जेनेटिक से ट्रांसफॉर्मेशन करना है, जेनेटिक इंजीनियरिंग में where you need E. coli for gene cloning like that. लाइट जल रही पल्लवी, लाइट एक ही जल रही है, इतना ही आप लोग?
सर सेकंड ग्रुप के 3 ही बच्चे हैं, तो थर्ड ग्रुप में से ही निकले
ओके, लाइट क्यों की है, कम ही आ जाता?
थर्ड ग्रुप के फिर सारे आए हुए थे इसलिए
इधर आ जाओ, थोड़ा सा इधर आ जाओ, तो आप ठीक है। So what we learned in the last class that how to grow the culture, how to maintain the bacteria, right? That is important in the one aspect. That if for the any industry, if you are working, you have to maintain number one the culture. That may be sometime important. But out of that culture, what are the metabolites you are going to use? It may be carbohydrate, protein, fat, or anything. One of the metabolites we are interested today is the bacteriocins. How these bacteriocins are separated. Right? Means if you grow the culture, bacteriocins are secreting peptides. There are certain metabolites which are inside the cell. Right? So if you are interested inside the cell, you have to take the cell. If you are interested in the protein which is outside the cell, you are interested in the culture process. So that suppose this is bacterium is growing, the protein will come outside. Protein will come in the medium. So you have to take the medium. And if it is inside then you have to take the cell. So here it is a simple example which is showing that there are proteins which are secretly in nature. While bacteria grow, they secrete outside. So they have taken this much medium while growing the bacteria. They have grown the culture. After the growth, they centrifuge and separate the bacteria. समझ में आ रहा है? इसी ग्रो करने के बाद बैक्टीरिया को निकाल दिया. अब क्या बचा? Medium, culture medium. Right? That medium is used is a mixture of protein. Now one protein is separated. That other proteins may be present in the medium. Because the medium is a mixture of proteins. One is bacteriocin inside that is added. Right? So our target is how to separate this bacteriocin out of the mixture of protein which is available. For example, it is a mixture of protein. आपको एक solution दिया हुआ है जो उसमें protein कई सारे हैं, हमें नहीं पता how many types of proteins are present. The question is how to remove one protein after the mixture. Mixture may be carbohydrate, protein, fat, lipid complex, all those metabolites which are secreted by the bacteria that may be present inside the solution. Right? What is being done the step first, that they are increasing the hydrophobic nature of the solution. If you increase the hydrophobicity, the compound will precipitate. For example, proteins are hydrophobic in nature. If you increase the hydrophobicity by increasing the salt, add 1 pinch of salt, don't put it outside, just inside. One spatula and add it. कम डालना इसमें से उसमें निकाल के. So if you are adding this salt, it means you are increasing the hydrophobicity. The water is hydrophilic. If you increase the salt, it means solution is become more hydrophobic. Once it become more hydrophobic, the proteins are hydrophobic. There are certain amino acids which are hydrophobic in nature. They are generally present in the protein. If they are present, if you increase the hydrophobic nature, these molecules will come together. Suppose this is one protein, this is another. That goes and interact together and make a clump. If there is a clump, it becomes heavy. When it becomes heavy, it gets settled down.
Yes, sir.
Right? Once it gets settled down, you can separate it by centrifugation.
Yes, sir.
Just make a centrifuge. The heavy
Settle down.
clump will be settled down.
Yes, sir.
Now suppose I added 30 grams of salt, 3 spatula for example, right? Then at that level the protein is separated. Now it's centrifuge. So what you did, out of the total mixture which was present, X amount of protein I removed. Okay? Now take that mixture and add more amount of salt. If you increase the concentration of salt, the smaller protein will now precipitate. Earlier, at the low concentration, larger protein will precipitate. For example, there are 3 different sizes of protein: largest, medium, and this
So
small.
that's why.
If a X concentration, which one precipitate first?
Larger.
Larger. Because the larger will have more surface area,
Yes,
so
sir.
they will interact easily. जैसे एक चौड़ा सा आदमी ऐसे जा रहा है तो कौन लड़ेगा जाके, कौन पतला वाला निकल जाएगा.
Yes,